Welcome to Maths with EJD. In this video, I'll be explaining the Python code for branch and bound method for integer linear programming problem, ILP. It was the same problem I solved manually in the previous video. Okay, and the problem is as stated, we have to maximize z equals 3x plus 2y subject to x plus 2y less than or equal to 5.5, 2x minus y greater than or equal to 1, then x comma y is greater than or equal to 0. That's the non-negativity constraint. And x and y now are both integers also. So that's the difference now between linear programming and integer linear programming problem. Okay, so that the fact that it has to be an integer, that is what we have right there, you know. So this is the code implementation in Python is now using both linprog in scipy.optimize and PuLP, which is a library of its own. Okay, so we have, as usual, we have the objective function. Of course, when you transform that, you have z minus 3x minus 2y. So that's why you have minus 3 minus 2 here. And then you have, for the first constraint, you have 1, 2. That's why you have 1, 2. But for this one, I know it's a greater than or equal to constraint, and it's always good to make it a less than or equal to constraint. And the way to do that is to multiply by minus. So you have minus 2x plus y is less than or equal to minus 1. Okay? And that is why you have minus 2 from minus 2x plus 1 from plus y. And then this minus 1 now, you now have minus 1 here in addition to the 5.5 that's still odd normally. So then, of course, you have the non-negativity constraint. And since we are using branch and bound method, so this is where we begin to define all of that. So we stack for nodes in the branch and bound tree, and then we have the best solution and objective found. So if best solution, none, best objective like this. So we have all of this going on to try to do the branch and bound. And by the time it's all done, we can just um, you know, click, just tap on that and we get the final optimal integer solution where x is 5 and y is 0. And the optimal objective function value for the integer linear programming problem is 15, just like we found in the manual situation. So if you come to PuLP takes a different approach. Interestingly, with less lines of code, we can we get to PuLP is like more straightforward, so to speak. For linprog, it's a bit more complicated. But for PuLP, as far as you just know the right things to call. So you define a problem in line 4. So if the problem is pulp.lp problem, we want to maximize pulp.lp maximize. And then 6, we define decision variables, which are integer variables. So we have pulp.l variable. So here, directly sets it to integer. We don't care what else. So this automatically just excludes the possibility of any of the variables being fractional or having anything to do with decimal part, right? So that's the beauty of PuLP. Then we have, PuLP is basically written specifically for optimization problems like this. So, and one beautiful thing about PuLP is that you can actually define the function directly. So you have 3x plus 2y, just like exactly what we have in the original problem. So you just define it in the Python way. So as the objective function, you have the first constraint, which is x plus 2y less than or equal to 5.5 constraint 1. Then you have 2x minus y greater than or equal to 1, which is constraint 2. And then all you just do is solve because we have already set it to integer directly. So we don't have to worry about any other thing. So we don't even need to go through the route of relaxed linear programming like we did manually. And if you click on this, right, okay, then here you just get all the output of the result, the status. If the result is possible to tell you, then you get the optimal XY and the objective function value that is also optimal. And those are printed out from lines 26 to 29. So if you just run that, that's what you just get. So it tells us the status is optimal, so it means we have found an optimal solution. And the optimal solution for x is 5.0, the optimal solution for y is 0, which we got manually also, and which we also got in using linprog. in the scipy library, and we have the objective function to be 15.0. So you see that thing we sweated over. I think that video lasted for almost 40 minutes when we're doing it manually. So with coding, it's these things are easier, and even coding can even handle bigger problems. Like if the constraints are very many, like maybe they are like n dimensional, like maybe 100 constraints or whatever. So this can actually do it more efficiently. And because there's so much to learn on this channel, of course, you do yourself a lot of good if you can subscribe. And then you also hit the notification bell so you can always get alerted each time a new video is released. And always remember to comment. Let me know if there's a topic you'd like me to teach in math, in Python, as far as it lies within my scope. And then also let me know if there's a problem you'd like me to solve. I solve quick problems too under Fast Math Solution playlist. And then like and share so that more people can have access to this great content. Till I come your way again, keep optimizing. Bye.